here we are in section 7.6, and we will use common logarithms to solve exponential equations like this. Now, a common logarithm has base 10, and you won't always see it. Typically, you'll just have something like this. It's just a log of 5, for example. If you were to see that somewhere, you have to assume that you are dealing with a log base 10. Alright, so we're going to use these common logarithms because the algorithm is on your calculators, and you can use your calculators to find an exponent base 4 that equals 19, that you could raise 4 to get 19. Because we talked about earlier in the chapter that 4 to the x equals 64. Well, we could create common bases. 4 to the x equals 4 to the third, therefore x equals 3. But now we're going to solve exponential equations like this. Or like 4 to the x equals 19. So when we do that, we're going to take the common log, base 10, of both sides. I'm not changing the problem, I'm just trying to solve for it. I can take the log of both sides, and I didn't change the problem. Similarly, like I can add 1 to both sides, or I can multiply by -1 both sides. As long as I do it to both sides, the value of the equation does not change. So log base 10 of 4 to the x on the left-hand side, I can go ahead and take this exponent and bring it out in front. I'm implementing my exponent property that I learned last week, so we can rewrite it as x times the log base 10 of 4 equals the log base 10 of 19. And the log base 10 of 4 is a number. It's an ugly number, but it's a number. And if we're trying to solve this equation for x, we can just divide both sides by that log base 10 of 4. And we see that we get, we're going to plug it into your calculator, x equals the log base 10 of 19 divided by the log base 10 of 4. And I actually want you to plug that into your calculators. It can be found, the log button can be found directly, adjacent to the 7 on your TI-84 or 83 or 89 for that matter, maybe. Well, I don't know about the 89. But the 83 and the 84, it's adjacent to the 7. So here we go. The log of 19 divided by the log of 4, and we get 2.1239. That's one way to go about it. Okay. So go ahead and try the next problem. 5 to the x equals 62. Take the log of both sides, log base 10 of both sides. We'll bring out the x. We'll divide the log base 10 of 62 and divide it by the log base 10 of 5, and we get x equals, let's see, 1.2528, and we are all set. The change of base formula is another way for us to write equivalent log expressions that have different bases. So on the previous slide we had exponential equations. Here what we will do is rewrite the log base 3 of 11 as the log base 10 of my numerator, 11, divided by the log base 10 of 3. And we could simply plug that right into the calculator and get a value of 2.1826. Now, on your homework, we ask you to specifically implement this change of base formula. If you were to be asked to solve this on a quiz, this is what we would give you. And if you forgot everything you knew about this change of base formula, you can simply go through the motions, rewrite in exponential form using your log loop, and from here you have an example very similar to the previous two. So we can go ahead and take the log of both sides, and let's see here, the log of both sides, and so x equals the log base 10 of 11 divided by the log base 10 of 3, and as you can see, it is the exact quotient from here. So go ahead and try the next one, the log base 10, or excuse me, log base 5 of 140. Okay, we see it should be 140 divided by 5. Now careful, do not take the quotient of 140 over 5 and then take the log base 10 of that. If you were to do something like that, you would subtract from your quotient rule, which we're not really interested in at this moment because it would take us a little bit longer to do. And just like that, I'm done. 3.0704, and we can use the fact that 5 to some x power, well, we now know 5 to the 3.0704 equals 140, but if we didn't remember the change of base formula, you can rewrite it in exponential form and then go ahead and take the log of both sides to find the exact same value. So that's the theme for section 7.6, common logarithms.